Our next speaker is Dr. Mario Werner, who is got a gold star background in sedimentology, having worked on his postgraduate studies in Namibia, working on the Cretaceous gross Bucharest carbonatite and in permanent sediments of the Mesosaurus Inland Sea. He arrived at the survey in 2011 via the Adelaide School of Petroleum at the University of Adelaide, and then in the Musgrave mapping team at the Geological Survey of Western Australia. He's worked all across our state in all of our projects pretty much, and he's also an active member of the South Australian Division of the Geological Society of Australia, so he's definitely my go-to guy when I need help with anything. Mario, thank you.
Thank you very much for that lovely introduction, Liz. So today I'm talking about the depositional age of metasediments that we have on the northeastern Eyre Peninsula and that form the host of South Australia's most important iron ore deposits. And so with this title slide, I would also like to acknowledge my colleagues that have contributed to and supported this study. So I will first show you the location of the study area, the Middleback Range, and give you a brief introduction to the regional geology. And then I will address the main question and topic of this talk, and this is about the depositional age of sediments and potential stratigraphic correlations. Then I will go through the history of the geological interpretations for the study area, and the changes that came on with the radiometric dating of sediments from this area. And then we have a look at seismic mining stratigraphic drill hole and the recent geochronology that was derived from this. And based on this, I will present a revised stratigraphy for the early Precambrian of the Eyre Peninsula, and will close with some remarks on open questions and some future work. So the Middleback Range is located in the northeastern part of the Eyre Peninsula in the upper Spencer Gulf region, and the area represents South Australia's oldest and largest iron ore mining district. The range forms a north trending about 65 kilometer long narrow linear belt of Precambrian metasediments that contain band and iron formations, and with numerous iron ore prospects and mines aligned along this belt. Mining started in the late 1890s and originally focused on hematite and goethite ore, with magnetite ore being mined since about 2007. And the ore is mined and processed here for export and steel production in Whyalla. So the regional geology overview. Geologically, the study area lies in the southeastern part of the Gawler Craton within the Spencer domain, which is separated by the Kalinshala shear zone from the magnetically and geologically quite different Cleave domain to the west. And the magnetite BIFs, which are encircled here in white, form strong magnetic anomalies in the TMI images, and these metasediments are preserved in sort of very narrow synclinal keels that are infolded within the older granitic basement rocks, and that's what causes their lenticular shape in plan view. To the south, the iron formations in the Bungalow-Minbury prospect area are considered a southwestern continuation of the Middleback Range BIFs and are separated from them by the Charleston granite, which is a Mesoproterozoic Hildebrand pluton. The Middleback Range metasediments are directly underlain by the circa 3 billion years old Kuyadu granite and are in turn intruded by Paleoproterozoic and Mesoproterozoic granites and the Neoproterozoic Gardner dolerites. So west of the Middleback Range and west of the Kalinshala shear zone, a circa 2.8 to 2.0 GA basement, which consists of the Kulanic gneiss, the Sleaford complex, and the Miltalic gneiss, is unconformably overlain by the Paleoproterozoic Hutchison metasediments. And to the east of the Middleback Range occurs a series of Paleoproterozoic volcano-sedimentary successions and associated intrusives. So the big question now that I want to address and try to answer in this talk is, what is actually the likely depositional age of the Middleback Range metasediments? Are they Paleoproterozoic and correlatives of the Hutchison metasediments, or might they be Archean and temporal equivalents of metasediments in the Sleaford complex? So what was the previous interpretation for the study area and a long-held view? So John Parker, who mapped extensively in the Lincoln Cleave uplands, and Nick Lemon, who mapped very detailed in the Middleback Ranges, correlated the metasediments of these two areas and combined them under the term Hutchison Group. So this correlation was mainly based on lithological similarities in the sedimentary succession, including the presence of banded iron formation and some common structural aspects. The succession in the Middleback Ranges was named the Middleback subgroup, forming sort of a subset of the Hutchison Group stratigraphy. The sedimentation was inferred to have occurred in the Paleoproterozoic between about 1950 and 1850 MA, and John and Nick developed sort of a depositional model of a single eastward deepening basin, ocean basin, with a succession representing and preserving two transgressive regressive sedimentary cycles. So this view was then challenged in 2011 when Mike Spooner published geochronological and isotopical data for metasediments of the Eyre Peninsula in Precambrian Research and in the MESA journal. A sample of the Cook Gap schist from the Middleback Range yielded an Archean maximum depositional age of about 2566 with no Paleoproterozoic circans present. So, and he further argued sort of like that the proximity of the about 2 billion year old Miltalic gneiss and the lack of the circans of that age in the Middleback metasediments points to a likely Neo-Archean depositional age for these sediments. In contrast, the metasediments from the Lincoln Cleave uplands clearly contained the Paleoproterozoic circans, yielding sort of max step ages between about 2000 and 1785 MA. And then, in addition to these data, a biotite garnet silimanite schist from the Bungalow prospect that was dated by Liz Jagosinski also yielded a Neo-Archean maximum depth age of about 2556, which is very similar to the Cook Gap schist age, and sort of confirms this connection between the Bungalow and Middleback BIFs. So this led then Mike Spooner to propose a major revision of the Hutchison Group stratigraphy. So what Mike Spooner suggested was that based on his data, the Hutchison Group, as originally defined by John Parker and Nick Lemon, actually consists of three groups of different age, separated by unconformities, and with the younger Paleoproterozoic Cleave and Dark Peak groups representing the metasediments in the Lincoln Cleave uplands, and the older Neo-Archean Middleback group representing the metasediments in the Middleback Range. And so consequently, he also speculated that the Middleback group could be a potential correlative of the metasediments in the Sleaford complex, which unconformably underlie the Cleave and Dark Peak groups to the west of the Kalinchala shear zone. So at that time, the proposal was met with a lot of skepticism and was largely ignored for a decade or more. So around 2020, Bill Kaiser from Adelaide University had a fresh look at the rocks of the Middleback Ranges and published some new geochronological data. So the geochronology of another Cook Gap schist sample confirmed the earlier Neo-Archean max step age. In addition to this, he also extracted circans from two amphibolite samples and again only found Archean circan populations, which he interpreted either as a magmatic crystallization age or as inheritance. But it actually doesn't really matter how you interpret these ages. The point is that Bill Kaiser's Middleback samples also did not contain Paleoproterozoic circans, which means that his geochronological data did not break or disprove Mike Spooner's revised stratigraphic scheme for the metasediments of the Middleback Ranges and the Lincoln Cleave uplands. So in 2022, CIMEC Mining drilled a stratigraphic drill hole in the Chieftain West area to unravel the stratigraphy of the Middleback Range. This is a government co-funded diamond drill hole, fully cored to a depth of about 890 meters. And it intersected the bulk of the Middleback Range stratigraphy, starting in the Cook Gap schist, and then intersecting the entire Middleback Jaspilite and Katanga Dolomite succession. And importantly, it also drilled about 6.5 meters into the underlying granitic basement. So when this core arrived at the Tonsley Core Library, we were quite keen actually to have a look and to take 1 or 2 samples for geochronology. So we used our portable XRF to check for the zirconium values. And so the Cook Gap schist, which is the top here in the images, is quite weathered and oxidized in this drill hole, but it has reasonable zirconium values, and it is clearly a siliciclastic sediment and should contain detrital zircons. So we took a sample, and we were able to extract zircons, so success. The magnetite BIFs of the Middleback Jaspilite, they have very, very low zirconium values. And that shows basically that these sediments are mainly of chemical origin with a very low detrital zircon potential. So we didn't take a sample here. Then the Katanga Dolomite in the lower part of the succession consists mainly of marbles and calc-silicate rocks. We weren't really able to identify sort of a meta-arenitic or meta-siliciclastic rock in this interval, which would be prospective for detrital zircons. However, some parts of the succession here had actually quite fairly significant zirconium values, so we did take a sample, but unfortunately it did not yield zircons. So this shows that this part of the stratigraphy is also predominantly composed of chemical sediments. At that time, we didn't take a sample of the granitic basement. That was sort of like not our main priority at this stage, and we were quite happy to interpret it as the Kuyadu granite. So this left us only with 1 sample of the Cook Gap schist, but again, sort of, it only contained Archean zircons with a Neo-Archean population defining a max step age of about 2556 MA, and the Meso-Archean zircons with an age of about 3.1 to 3.3 GA can be easily attributed to the granitic basement of the Middleback Range, such as the Kuyadu granite. And so we pooled all of these available ages from the southern Middleback ranges together, and that resulted sort of in an average max step age of about 255 MA for the Middleback Range metasediments. So looking for potential correlatives, this age is slightly older than that of the 2525 MA Hall Bay volcanics of the Sleaford complex, occurring along the western coast of the Eyre Peninsula. However, this age is basically the same as that of the Devil's Playground volcanics occurring in the eastern Mulguthin complex between Olympic Dam and Prominent Hill to the north of the Middleback Range, with the area in between covered by the Mesoproterozoic Gawler Range volcanics. And the Mulguthin complex is basically interpreted as sort of an equivalent of the Sleaford complex in the northern part of the Gawler Craton. So where does this leave us with the Hutchison Middleback stratigraphy? So at this stage, we recommend to largely accept Mike Spooner's stratigraphic scheme with some minor modifications and additions. So we suggest to elevate the Hutchison Group to a supergroup so that it can incorporate the Dark Peak and Cleave groups, and to apply these terms to the Paleoproterozoic metasediments in the Lincoln Cleave uplands. We also propose a younger age limit of about 70-70 for the Hutchison supergroup in order to separate it from the unconformably overlying Wallaroo group. Then we also suggest to elevate the Middleback subgroup to a group and to exclude it from the Hutchison supergroup due to its likely Neo-Archean depositional age. And the term Middleback group should be exclusively applied to the metasediments of the Middleback Range area. So there are still some open questions concerning the Middleback Range geology. For example, the presence and the distribution of a basal quartzitic unit is not very well established and documented. And at the top of the succession, the nature of an upper jaspilite unit is still a bit unresolved. It's either interpreted as a true stratigraphic unit, or other people see it more as a representing a tectonic repetition of a single jaspilite unit. In terms of the metamorphism, we would like to have a clearer picture about the PT conditions and also the timing of the metamorphism. And it's probably worth also to reassess the iron ore prospectivity of the wider Eyre Peninsula with a BIF potential in the Sleaford complex. So some of these questions will be addressed in an upcoming magnetite study under the leadership of Mitchell Bockman. He and several other survey geologists have recently visited the CIMEC geologists in the Middlebacks to look at outcrops and mine exposures and also some drill core, and they collected some more samples for further studies. So we will see if the possible and likely Neo-Archean depositional age of the Middleback Range metasediments are holding up. So stay tuned and watch this space, and thanks for listening.